Hello, today we'll be talking about systems of equations. System of equations are very interesting to me because they are something that are a way to think about math more in depth. It is when a solution has more than one variable that is either unknown or um, or something that is known but is kind of a constant. These letters can consist of X, Y, Z, T. Yeah, it continues on. It doesn't necessarily matter because it is a symbol of exactly what you're trying to find. Yeah, it will be two or more equations. So an example of this, if I can just pop it up really fast. Okay. Okay. So an example of this would be this. This is a system of equation and it is solved by elimination. There's different ways to solve systems of equations like elimination, substitution. I'm sure there's other different methods, but those are the main methods that you should remember. By elimination, I mean either completely erasing, or I mean completely deducting one of the variables. Like if you look here, you can see y is completely deducted, leaving only x. And once we find out what x is, then we'll be able to, since in this example we can see that x is 3, and yeah, since x is 3, we can use this and we can plug it into an equation. And yeah, okay, this image might not be like the greatest example. Let me pop up a couple more examples that we can do together. Feel free to pause the video when we do the solutions and answers, and so that you can better understand it. Okay, so a couple different things that you'll see in systems of equations is that they won't necessarily always this applies to pre-algebra as well, algebra, anything, but it necessarily won't have it won't be guaranteed that there'll only be one solution to the equation. But what I mean by this is that as long as as long as um as long as the two variables are somehow connected to each other, and they okay, let me do a little okay, one of the ways, what I'm talking about right now is a system of equation could have only one solution. And by one solution, it means that the ordered pair of the two equations or more, they only intersect at one point. So if it was in a graph, it would look like this. If the two solutions went like this. Let's say this is 1/2, -1/2 x, and then let's say that's how it's going down, and that equals y. Okay, and then there's another solution, and basically, and it only intersects at one point. That is why it would only have one solution, because that is the only place that of the both of the equations intersect. So one solution. So no solutions is kind of it would mean that there's the lines don't intersect at all, no matter where or how. Those two lines, the only way this could happen, or the most obvious one, is that if the lines are parallel to each other. For lines to be parallel to each other, they'd have to have the same slope but different. Here, let me do another example. So the lines would look something like this. Yeah, this is a symbol I'm doing to show that they're gonna be like parallel. So basically, if it was like 2x minus 1 and 2x plus 2, these would never intersect at all since the slopes are the same and the intercepts are different. It would not be possible for it to intersect at all because they are going up by the same amount. And if they go up by the same amount, it means that they're never going to be touching. It's going to look like a parallel, like just going straight up, that amount being the same distance away from each other through the whole course of both directions that they go. Okay. And the final one is an infinite amount of solutions. An infinite amount of solutions. So this I believe, at least in my past experience, that infinite solutions are very like easier to spot than the other equations. The reason for this would be that they lie directly on top of each other. Yeah, they lie directly on top of each other. They are the same thing. They're the same. They lie on the same line. So 2x plus y equals 10. 2x plus y equals 10. Yeah, this is, well, except the 2x equals y, 2x equals y. They're the same line, the same equation, the same answer, no matter what you plug in. If you plug in 1, plug in 2 for x, plug in 3, it's just going to be going up like that. It's going to be the same line. So it's going to have an infinite amount of solutions. It intersects in every single place. Because it's the same, like, you could say the same line, but they just lie on top of each other. Okay, let's do a couple practice problems. I hope this will help you understand it better. Okay. Overall, a quick recap is last time we were talking about Algebra 1 in general. System of equations are part of Algebra 1, and it's just going more in depth. In Algebra 2, you'll see equations that are with like 3 equations, and sometimes there can be an infinite how I describe it is that systems of equations are a set of stimulus equations. They are also known as systems of equations. Oh, and they have an infinite set of equations which has the common solution. Yeah. So for the first problem, we can see that y is already given to us. We don't need to do a lot in there. And to solve this, so since we know what we're trying to find out here is what y is, and it says right here, y equals x. This is a very simple problem. So we can take the y and plug it here, since we know that y equals x. So y equals 5. So since we know y equals 5, we can just take 5 and plug it in the place of y. So we know y equals 5. So the equation would look like this for the top. So what would we do first? What do you think we do? Pause the video if you have a good idea of what needs to be done. I'll wait. Okay, so we subtract 3 from both sides. What we do to one side, we must do it to the other side to get rid of this extra. Yep. Then we'll have 2 left. Which would equal 1/2 x. And we can see that since this is 1/2, if we multiply it by 2, or 2/1, it would equal x. And if we multiply this side by 2/1, since we have to do, when we do something to one side, we have to do it to the other side, this would equal 4. So here, y equals 5. And x equals 4. Y equals 5, x equals 4. Yeah, you would write it in lowercase, but yep, that's how to sum up the first problem. So for the second problem, it looks a little bit more difficult, but the same concept is applied for that problem as well. Okay, so here it says 9x minus 2y equals 19. And on the bottom, the second equation, it says 7x equals 21. So right off the bat, I can see something that we can do that will definitely ensure that we have a more simplified answer. If you look at here, if you see 7x equals 21, you can do something to simplify this a lot. I mean, yeah, you can simplify equations by themselves, but you have to do it to both sides. So what I mean by this, 7 and 21 are known on the second equation. If you take 7 and 21, do they have a common do they have a common number that they can be both divided by? what would that number be? It would be 7. We can divide both by 7. Because when we do something to one side, we have to do it to the other. So if we divide both by 7, we will get x equals 3. And that means we simplified it. And we really didn't need to overcomplicate it. And that is obviously much better than overcomplicating it and not being able to understand how to get the answer in a simpler and more efficient way. So x equals 3 for the bottom. X equals 3. That's something that's good to know and really helpful, in fact. So once we know x equals 3, we can use this knowledge and apply it and take the 3 and plug it in here. So let's do that. Okay, so let's see what it says. 9x, 9, we're plugging it in. So 9, 3 minus 2y equals 19. 9 times 3 is 27. Minus 2y equals 19. We could, do you see anything here that can be, subtracted over here? Or what can we simplify? I see that we can simplify this and this. We could subtract 27 from both sides. Okay, so what do you get once you subtract 19 minus 27? Remember that we're subtracting a smaller number to a bigger number. We're subtracting 19, which is a smaller number, to a bigger number, which is 27. Oh, we're subtracting 27 to 19. So it would equal a negative number. It would equal -8. And we'd still have this to keep in mind. So negative 2y equals 8. And what would we do here? How do we simplify this even further? If you said that we would divide -2, you were correct, because that is what we would do. Because the opposite of multiplication is division, and so forth. And once we divide -2 from both sides, then the answer would be y would equal 4. Because a negative divided by a negative is a positive. Okay, try to solve this equation and this equation by yourself and see what you would get. Okay. So in this equation, we can see that y equals 9, and we can plug it. We can see that y is right here. Substitution. We can plug it in here. So once we take y and plug it in, 1 second. Okay. So once we take y, okay. So then we can say 9 equals 9x minus 9, because we plugged it in. We would add 9 to both sides. And after adding 9 to both sides, we would have 18 equals 9x. And then we would divide to count to do the opposite of multiplication. We would divide 9 to from both sides, since 18 is divisible by 9. We would do it either way though. 18 divided by 9 would equal 2, and x would equal 2. X equals 2. And as for the next way to think about this, it would be that y already says it's equal to 9. We don't have to like overthink this one. It's going to be y equals 9. Okay. So for the next equation, it says, okay, this is definitely something that will be a little bit more challenging, but it's still going to be okay to be able to answer right, obviously. So let's see. So we can see that actually this is very interesting to me. It says here y. This is what y equals from both sides. So what have we been doing here? We've been taking what y equals and switching it over here. What can we do here? What do you think that will be the similar or the same in your eyes? We would take this number, this equation, and this part of the equation, and they would equal each other because they both equal y. And if they both equal y, that means they would equal each other. I hope that makes some sense. So we would so they both equal y, so they would both equal each other. So basically we're just taking, let's say for example, 1/3 x plus 1 equals y. So if that we know that equals y, that means we can just substitute it with the other y on the top left side of the, which is y equals 4x minus 10. Let's do that. Okay. This is a very good equation. So let's do two things at a time. Actually, over here we can just, so since this is -10, it'll be easier to handle if we just added it to both sides. Add 10. Add 10 to both sides. And then we would have 4x, which would equal 1 over 1/3 x plus 11. And we would subtract 1/3. So 3 and 2/3 x would equal 11. Okay, this is where the situation gets. Okay, this is definitely something that you could use a calculator for, but if not, then you could just take you would divide this number to this number, or you would divide this number to both sides. So 11 divided by 3 over 3 over 2/3. If you use a calculator, make sure to use parentheses when needed. It would be 2.4 repeating. It's also a good idea to check if your solution is correct by plugging it into the equation later, which you could have done for any of these. And since we know that is what x is, we can use this equation. We can probably just do this off the top of our heads or a calculator. So 2.4 is what x equals, right? So we can take that and multiply it by 4 from the first equation, and then subtract it by 10, and we would get negative 0.2 repeating. Which is what would equal y, and x would equal. I'm not too sure about this actually. Here, let's use what we know here. Let's actually check the answers. So we can plug this into a calculator. Let's see. So if we take 2.4 repeating, and since that is x, let's use the first equation for this. If we take 2.4 repeating and multiply it by 10, multiply it by 4, we would get 9.7 repeating. And if we subtract that by 10, we would get negative 0.2 repeating. And yep, that would be the answer to the solution. So yep, if we check this, it would work. If you write it down, it can be a check. So in both scenarios, it would equal 0.2. Repeat. So yeah, it works. Yeah, the same thing will happen once you solve all of these. There'll be different solutions, and sometimes it won't have a solution. But yeah, so for this one, we know what y is. Y is 2. Just write it down here. X would be, so plug into here. So so 2 equals negative 4 over 3 x plus 6. That would equal, we'd have to subtract 6. Subtract 6 from both sides, and then we would be left with if you subtract 2 minus 6, it'd be negative because it's positive, and then a bigger number that's a negative. So it would be negative 4. So we would multiply this to both sides, and that would, well, we would multiply 3 and then divide by 4. So we would multiply. Oh, sorry. We would divide. Somebody tried to correct me through the video. We were right. Divide. We would divide by. We would divide actually by the opposite of the equation. So it would. We would divide by negative 3 over 4. And that would, somebody has a calculator. And that would be, well, we know it'd be a positive since there's 2 negatives we're dividing by. 5.3 repeating. Okay, so we know this is 5.3 repeating. Yeah, we would multiply it by this, add it with 6, and see if it equals 2. So we would take negative 4 over 3 and multiply it by 5.3 repeating. then add 6. So it'd be negative. Oh, I think this is wrong actually. Okay, okay, that's fine. That's part of math. Let's go back and see what happened. So we took y equals 2. Yes. And then it equaled negative 4 divided by 4x plus 6. Okay. We subtract 6 from both sides. Yeah. Um yep. And then we divided by negative 3 over 4. So dividing by negative 3 over 4 would so once we divide it by oh, I see. Okay. So we multiply it by 4 times 3 over 4, which would equal, then x would equal 3. Yeah, that's the beauty of math. It it it's kind of a trial and error at the start, and you'll understand it better as you keep practicing. This is why practicing is important. Even for me, I've been doing it for years, and it seems that like simple mistakes like multiplying and dividing can really get you. So basically you multiply it because if you switch the fractions from the denominator to numerator, you're basically going to be dividing it because it's a fraction, and if you divide in a fraction, it's going to get you an even more complicated number that is not going to be the answer. So x would equal 3. Let's plug it into the equation. So if we plug in 3, then we would have negative 4, and minus 4 plus 6 would equal 2. And what is y? Y is 2. The solution is correct. X equals 3. Yep. Okay. So, yeah. For the next solution, okay, we can see that we can't simplify anything, and we also cannot necessarily eliminate. That will get us into an, like, it won't be.